This video will help you prepare to retake the assessment for Thermal Energy Standard 1. The temperature of an object is related to the kinetic energy of its molecules, which increases as the speed of the molecules increases. This list of scientific principles will help you prepare for retaking this assessment. We're going to take a moment to review each one of these scientific principles. The first thing we need to look at is this animation that we watched in class at the beginning of the unit. If you look at this picture over here, you can see that there are these small gray circles that are filling up this object. Over here, there's a little animation, so let's watch that. In this animation, you can see that when you click on the cup of water, that you can zoom in and see these small gray circles that are moving around and vibrating and have lots of energy to them. So let's try to understand exactly what this is trying to show us. The one thing that we can learn is the little spheres represent water molecules. Molecules are in constant motion. They're moving all the time. So in the scientific section divider, in our section divider, we added this new vocab word, molecule, a group of atoms joined together in a particular way. And we can see that this is an example of a water molecule. There's some atoms of oxygen and hydrogen that are grouped together in a particular way. In later units in chemistry, we'll learn more about molecules and what they are. But the thing that we need to understand for this unit is just that molecules make up everything, and all objects are made of them. The things around us, even very small things, are made of billions and billions of molecules. We can't see them, but the sim has made them very large so that we can observe what's happening to them. So the first scientific principle to add to the section divider in this unit was things are made of molecules or other types of atom groups. As we explored in our unit, we read this article that had a picture here of a cup of ice water. And if you look here, you can see again those little gray circles that represent molecules. And this time there's something different. There's these little tiny lines here. Because this is a still image and not an animation, those little lines there are meant to represent molecules in motion. Those are motion lines. If you look at the molecules in the hot cup of tea on this picture, you can see that the motion lines are much longer. And this is to show that the molecules in the cup of tea are moving faster than the molecules of water in the cup of ice water. In the article, as it began to talk about how the molecules in objects that are colder are moving slower, and the molecules in objects that are hotter are moving faster. And we read this quotation. This is because temperature is a measure of an average molecular movement, and there is a limit to how slowly something can move. After all, if something slows down completely, it just stops moving. And it was beginning to introduce us to this pretty interesting concept about how molecules are always in motion. One of the things that we also read in the article and throughout our discussion in our unit was about the word energy. Energy is just the ability to make things move or change. And when we're talking specifically about the move part of energy, we can refer to that as kinetic energy. We recorded this in our scientific principles list and our vocab list as kinetic energy, the energy that an object has because it is moving. So if a ball is bouncing, we would say that it has kinetic energy. Although we can't see the molecules inside of an object that is completely still, the molecules inside are still and moving around. So in this unit, we explored how temperature affects those things. So one of the things that we first did was we looked at the sim. So let's take a look at that and understand exactly what we're learning from that. Okay, here's what the sim looks like. So let's add a sample to the sim. We'll just make it large so it's nice and easy to see. I'm going to select the toggle for view kinetic energy, and then I'm going to add some energy by clicking on this plus sign, and a little hot coal is going to make the molecules right next to it get very, very, very hot. We can see here that the yellow color refers to a high energy and the gray color refers to a low. At the beginning, when we were first transferring energy in, it moved throughout the object, and at this point now you can see that all of the molecules are moving much more quickly. Now I'm going to remove energy from the system, and you'll see that the molecules will begin to move around more slowly. The sim is trying to teach us that objects that are hotter are moving more quickly, and objects that are colder are moving more slowly. In our list of scientific principles, we added this statement. When a thing gets hotter, its molecules are moving faster and have more kinetic energy. And this is something that we learned directly from the sim. We also learned from the sim that when a thing gets colder, its molecules are moving slower and have less kinetic energy. So as we were talking in the sim about the temperature of an object, we realized that although the little gray circles in the object were all moving, some of them were moving more quickly than others at certain times. Some appeared to be gray or yellow, depending on how much energy they had. But temperature, although it also tells us about how hot or cold an object is, and the kinetic motion or kinetic energy of the particular molecules, we understand that temperature is a measure of the average speed of all of the molecules in that thing. The word average just means it's a way that we summarize data. In class, we spend a lot of time reviewing how if you add all the numbers together and divide it by the number of numbers, you can find the average. And as we saw in the previous slide, the average means the average speed or kinetic energy of the molecules. Okay, so let's take a look at an example assessment question. You are going to be retaking the questions for the Thermal Energy Standard 1. This is an example of the kind of question that you might see. So let's take a look at the question. It says, lava is a hot liquid rock. When lava flows over solid ground, the solid ground beneath it increases in temperature. What happens to the molecules in the solid ground when the temperature is increasing? So the first thing we want to take a look at is the second sentence. It says, when lava flows over solid ground, the solid ground beneath it increases in temperature. And what this sentence is teaching us is that lava, which is a hot object, is in contact with something else, which is the ground. And the ground is much colder than lava. As lava and the solid ground come in contact, energy is transferred from the lava to the ground. So we want to know how this energy transfer is going to affect the motion of the molecules in the ground. The question says, what happens to the molecules in the solid ground when the temperature is increasing? So the first thing that we're going to notice about these individual questions is this first question says, more heat molecules combine with the molecules in the ground. Now, we know that molecules are groups of small atoms that make up all objects in the universe. Every object is made of molecules. These would be molecules of water and molecules of gold and molecules of any kind of substance, but heat is a type of energy. Heat is not a molecule. Heat is energy. This does not make sense. This first question is clearly wrong. Heat molecules is not true. So we can eliminate that from our consideration and just look at the next three questions. The next three questions include the word energy. In the first, in question 2, it says cold energy. Question 3 and 4, it just says energy. So let's take a moment to try to understand what cold energy means. Kinetic energy is the energy of motion. Energy is the ability to move or change something. The word cold is a word that refers to the temperature of something. You could say that ice is colder than water or something like that. The word cold is not a word that describes kinetic energy or something like that. It's just a word that describes temperature, which is the average kinetic energy. In this case, the cold energy is not a real thing. So again, just like question 1, we can eliminate that from consideration. Energy could be called kinetic energy, but it could not be called cold energy. So if we look at the last two questions, let's try to understand how they're different. If you look at them, you can see they're almost the same until we get to the end. The energy of the molecules in the ground decreases, or the energy of the molecules in the ground increases. And so if we review the question where it says when lava, again, a very hot substance, flows over solid ground, the solid ground beneath it increases in temperature. What happens when a molecule increases in temperature? What happens to the motion? We learned from scientific principle number 2 that when a thing gets hotter, its molecules are moving faster and have more kinetic energy. And we can use that information to help us understand this question. So we can see that the most correct answer is going to be question 4, because the energy of the molecules in the ground is increasing. When the temperature increases, the molecule's kinetic energy also increases.